Good morning, the participants of all the remote centers and the participants at NITER Chandigarh. So today we are going to learn about the Perceptron algorithm and then backpropagation algorithm, start some programming in MATLAB in neural network. So first session I am going to tell about the Perceptron algorithm and the Perceptron convergence algorithm. Now, Perceptron algorithm has been developed in 1960s. It was the first neural network learning model. It was simple and very limited because single layer models we used to use in Perceptron algorithm, and basic concepts are similar for the multi-layer models. That means if you want to know the single layer model, that the algorithm of convergence for single layer model, then of course you can extend it for the multi-layer models. And it is very widely used in current research problems also. So Perceptron basically has been developed by Rosenblatt. So if we want to know the logic expression of the perceptron node, then from the figure itself we can see that this is your x1, this is your input x1, this is your input x2, and this is your input xn. There are n inputs are there. Similarly, with all inputs the weights are connected, w1, w2 and wn. Perceptron algorithm says that when the net we will find out, net, you know, net is equal to that, yesterday class also we have told, net is equal to summation of the xi into wi for I is equal to 1 to n. So this is your net. So Perceptron algorithm says that if the net is greater than equal to threshold, then it will be 1. And if it is less than equal to threshold, then it will be 0. How the weights will be updated, that will come later on. So let us see one example. For example, x1 and x2 it is given. This is your two inputs, x1 and x2. The weights I have given, that is your w1 equal to 0.6 and w2 is equal to minus 0.4. And the threshold I have given that theta is equal to 0.1. That I have given, that is theta is equal to 0.1. Now let us, the example is that x1 and x2, and this is the target. That means first is your x1 is your 0.8, next is your x2 is equal to 0.3, and then the target is given, that is equal to 1. But in the next case, the x1 is equal to 0.4 and x2 is equal to 0.1 and the target is 0. Now we will see that how we get the actual response and how we get the error and how it will be modified. The weight will be modified. Now first of all we will see that when we are inputting 0.8 and 0.3 and the weight is your 0.6 and minus 0.4. So what will be the total sum of xi into wi? That will be 0.8 into 0.6, right, plus 0.3 into minus 0.4. So that will be your total xi into wi. That you can calculate that it will be 0.36. That means 0.8 into 0.6, 0.48 minus 0.12, that is equal to 0.36. Now our theta is equal to 0.1, that means it is greater than theta, 0.36 is greater than 0.1, that means the output we are getting as equal to 1. That means output we are taking as z equal to 1. Our target is also equal to 1. So we will not change any weights. That means we are getting the target as 1 and we are getting the output, our output actual response is also 1. So there will be no updation. Now let us see that these weight are applicable for the, that is 0.6 and minus 0.4. Will they be applicable for the second one also or not? Now for the second one, Again it is giving that input is equal to 0.4 and x2 is equal to 0.1. Then what will be the output? We will say 0.4 into 0.6 plus 0.1 into minus 0.4. So what we were getting, that if you calculate, then we are getting 0.24. That means you will getting 0.24, which is again greater than 0.1. So we are taking that output will be 1, because if it is greater than the theta, then output will be 1. But when we are taking care of the target, we have seen that target is equal to 0 and we are getting the output is equal to 1. That means some weight adjustment will be there. Now what will be the weight adjustment? Now perceptron algorithm, Rosenblatt says the weight algorithm is the delta W equal to T minus Z into C into Xi. T minus Z, that means it is telling T is your target. Now for example, our case, T is equal to 0, Z equal to 1 and C is your learning rate. Let us take C is equal to also 1. Right, maximum value it can be 1, that is your learning rate. And Xi we know, first time Xi is your 0.4 and another time Xi is equal to 0.1. Now let us calculate a delta W1. Now what will be delta W1? That will be T minus Z. T is your 0, Z is equal to 1, C is equal to 1 and Xi equal to 0.4. That means the delta W1 equal to minus 0.4. That is your delta W1. That means what will be the new W1? The old W1, that is your W1 old plus delta W1. So what is your delta W1 old? That was your 0.6 and now it will be minus 0.4. That means new W1 it will be 0.2. That means now wherever we will update the weight, so our W1 has become 0.2. Now similar case of W2. Now W2 is your old W2 is your minus 0.4. Now let us find out that what will be the delta W1. Now delta W1 will be delta W2, sorry. Now let us write here. Then delta W2 will be what? Delta W2 will be 0 minus 1. That is also 0 minus 1 only. That will be minus 1 into C, that is your 1. That means minus 1 into 1 is 1 into X2. X2 is your 0.1. That means delta W2 we will get minus 0.1. Right? Now if we take the minus 0.1 plus this W2 old, we will be getting the new W2. That means our new W2 will be minus 0.5. So this is your the new W1 and this is your new W2. So this way Perceptron says that this way you have to update your weights. Now this is your one training process, that is known as your one epoch. It is known as your EPOCH. That is your one epoch we have completed. Now for the next epoch, that is your new W1 and new W2, again we have to calculate that with 0.8 and 0.3 that whether we are getting the same target or not. Just 1 minute, let us include another blank slide so that I can just show you the next calculation. Right, this was our main calculation, that was previous we have calculated. Now what happened? Right, now that means in our case what we are getting now, that is your new new W1 we have got is your 0.2, right? And W2 we have got is your minus 0.5. And the input we have, that is your 0.8, 0.3 and 1, and 0.4, 0.1 and 0. Let me write it. That is, we have got input is your 0.8, then 0.3, target is your 1, and next one 0.4, 0.1, target is equal to 0. Now for this target we have found out that there is a weight updation, and finally we have found out W1 new and W2 new. Now we have to check that with this W, is the first one is also matching or not. Now let us see that first one. For the first case, again we have to calculate x1 into W1 plus x2 into W2. Let me see that x1 into W1 will be 0.2 into 0.8, right, or 0.8 into 0.2, and minus 0.3 into 0.5, right. Now here we are getting that 0.16, here we are getting 0.15, that we are getting 0.10. Now in our case, the theta is also 0.1. That means if it is greater than equals to theta, then also we will get 1. So in this case it is equal to theta, so that's why the output will be equal to 1, right. So we have found out that first of all we have considered that W1 and W2 as your 0.6 and 0.4, but finally when you will do, you can do the updation, and finally with the new updation you have to do it again. Now when you will do it again, and if you see the target are for all the inputs, the target are same, that means you have done the final perceptron, or you have got the perceptron convergence point, right. So that is known as your perceptron convergence point. Now if we combine this concept, so we get that perceptron rule learning, it says that dwi, that means delta of wi or the changes of wi is equal to c into t minus z into xi. This is your actual algorithm or the actual weight updation. C we know, that is your learning rate, t minus z I have told you, and xi is your input. So only we change weights if there is an error. That means if there is an error, then only we will change. Perceptron says that. Otherwise it will not be changed, right. Otherwise it will be same as your this. If it is, there is a change in weight, then only, if there is an error, then only we will change the weight. Otherwise if they are the target and original values or the actual response is it is same, then we will not change the weight. And it will be also scaling by xi, that means it will be multiplied by xi. So you have to remember that in perceptron algorithm the weight updation is this. In various learning method, the various types of the weight updation is there. That is only the difference in case of the different learning rule, right. So it says create a perceptron rule learning method. There are the methodology says that create a perceptron node with n inputs, iteratively apply a pattern from the training set and apply the perceptron rule. Each iteration is known as your one epoch, that I have told that one training process is known as your one epoch, and it should continue the training until the total training set error ceases to improve. That means all the inputs have the equal target value, then only we will say that training is complete. And perceptron convergence theorem, it says it is guaranteed to find a solution in finite time if the solution exists. If the solution exists, then we will get the final solution. Now let us take one example again. It says how to calculate. It says there are 3 input perceptron values. The values are, it says the 0, 0, 1, this is one value, x1, x2 and x3. There are 3 inputs. Another one is your 1, 1, 1. You can just do it on your in your copy also. Another is your 1, 0, 1. This is your third input. And another one is your 0, 1, 1. This is your fourth. That means x1, x2, x3. There are 4 values of x1, x2 and x3. And these values are the target. That means for the first one, 0, 0, 1, target is 0. For the second one, target is 1. For the third one, target is 1. For the fourth one, target is 0. Right? We want T, we want the inputs x1, x2 and x3. What else we want? We want C. Let us take C is equal to 1. Right? And another thing, what do you want? If you want to give the bias, right? That is your own wish. If you want to give bias, you can omit also or you can give it also. In our case, we are taking bias B equal to also 1. So there are 4 inputs, x1, x2, x3 and then B. That is your bias, right? Bias weight is equal to +1 and in the input also +1. That means multiply, it will be only +1 only. So let us make the table. So this is the table we have put. That 1 is your pattern. Pattern gives you the x1, x2, x3 and B. So on the first case, 0, 0, 1, that is your x1, x2 and x3 and B is your 1. Every time B will be equal to 1. So we are getting 0, 0, 1, 1. Then we are getting target. Here we are getting target is equal to 0. We have put target is equal to 0. First of all, to start with, we are taking weights, that is W1, W2, W3, W4. Those weights are 0, 0, 0, 0. These weights are 0, 0, 0, 0. Now, what will be the net? What will be the net? We have got the equation. We have got that x1, xi into wi, right? I is equal to 1 to 4. Why it is 1 to 4? Because x1, x2, x3 and another one is your bias, that is your 1. So we are getting, if we do the plus or multiplication of this, you get 0 into 0, that will be 0, right? 0 into 0, that again will be 0. 1 into 0, that again will be 0. And 1 into 0, then again it will be 0. That means total net will be equal to 0. So that I have written, that is net equal to, here we are getting net equal to 0. If the net equal to 0, so what will be the output? Output also will be equal to 0 because we have taken the condition. If net greater than 0, then the output will be 1, else it should be equal to 0. We have taken the condition according to our requirement. So an output is equal to 0. So if the output equal to 0, we know that what is the formula of dw? We have got C into T minus Z into Xi, x1, x2, x3 or x4. So dw1, dw2, dw3 and dw4. So here target is also 0 and net is also 0. That means 0 minus 0 is 0. That means every time you will get dw is equal to 0, 0, 0, 0. That we have got for the first one. Right? Now for the second one, if you get the 0, 0, 0, 0, now next input will be what? 1, 1, 1. Now for the second one, 1, 1, 1 and bias is also equal to 1. Right? In our case, what is the target? Target is also equal to 1. But now it is, what is the weight? Because delta W is also 0, 0 and previous value also 0, 0, 0, 0. So the new value of weight will be 0, 0, 0, 0 only, because we know that W1 new will be what? W1 old, right? Plus delta W1. So in our case, delta W1 is also 0 and W1 old also is equal to 0. That means W1 new also will be equal to 0. Similarly, W1 new, W2 new, W3 new, W4 new, right? Again, we will calculate the net. Now, in this case, again net will be equal to 0. Because if you multiply this one, each and every x1, x2, x3 and x4 with the W1, W2, W3 and W4, you will get again 0. Now again output also will be 0 because according to this condition. Now what will be dw? Now our target and output is different. Target is your 1 and our output is equal to 0. C equal to 1. That means delta W or dw 1, what will be 1? C equal to 0. T is also 1. Z equal to 0 into xi. Xi is what? xi is your 1. That means delta W is equal to will be delta W1 will be equal to 1. Similarly, you can get delta W2 also will be equal to 1, delta W3 also will be equal to 1, delta W4 also will be equal to 1. If it is 1, 1, 1, 1, then for the third case, that is your 1, 0, 1, these are my input, and another bias that is also equal to 1, and here also we are getting target is also equal to 1, so we have written target is also equal to 1. Now what will be the new weights? New weights will be W1 old, that means 0 plus the delta W1, that will be 1. So in this case we are getting 1, here also 0 plus 1, that will be equal to 1, here also 0 plus 1, that will be equal to 1, and 0 plus 1, that will be also equal to 1. So this is your third step. Now next, what will be the net? Now again we will do the multiplication and summation. We will get net is equal to 3. Now if net is equal to 3, that means greater than 0. That means output will be equal to 1. Now here in this case the target is also 1 and the output is also 1. Here getting for the third case target is also 1, output also you are getting 1. Again t minus z will be 1 minus 1, again you are getting 0. So every term delta W1, delta W2, delta W3, delta W4 equal to 0. According to our concept also, Rosenblatt says that if the target and the output is equal to same, then there will be no weight change. So here also calculation, with the calculation we are getting that there is no weight change, right? Now there is no weight change, that means for the fourth case, that is 0, 1, 1 and bias is equal to 1, the target is equal to 0, and here will be same as your W1 old or W2 old. So we are getting the same value of the weights, that is new value of the weights will be 1, 1, 1, 1. So again we will calculate, again the net will be 3, again the output will be 1, but here in this case again the target is 0 and the output is 1. Again we will be giving the t minus z, that is 0 minus 1, and formula we will put, and finally we will calculate the delta W1 and delta W2 and delta W3, delta W4, that is 0, minus 1, minus 1 and minus 1. Now this is your full epoch. That means finally after one epoch we have found out that output of this weight will be, the final weight will be 1, 0, 0 or 0. There are 4 weights, and the values which we have completed, that is your fourth values we have completed. Now again with these weights we will start from the first one, again from the new one, new input, again we will start the training procedure. So that's why we will get this complete values, and finally we can see that for the 4 values we are getting the same, that is 1, 0, 0, 0. That means we are getting the same target. You see that 0, 1, 1, 0, that was our target value 0, 1, 1, 0, and finally we are getting the output also 0, 1, 1, 0, and there will be no weight change. Here also there is no weight change, here also there is no weight change. So finally the weights are 1, 0, 0, 0. That means when you will train the inputs again and again, so weights, the updated weights every time, now you will get 1, 0, 0, 0, and that means that you have come to the convergent value, that is your 1, 0, 0, 0, right? So final rules, it says that if t is equal to 1 and z is equal to 0, right? If t equal to 1 and z is equal to 0, then W new equal to W old plus P. Plus P means P is equal to neuron, the input of the neuron, that is your Xi. That is, if target equal to 1 and you are getting 0, that means you are getting the less value, you have to do the increment or the positive or the addition. And if the target is equal to 0 and z equal to 1, then you are getting the minus p. From the rule also, from the formula also, we say that delta W is equal to C into t minus z, right? T minus z. So if t equal to 1 and z is equal to 0, that means you are getting the positive value. and if t is equal to 0, z is equal to 1, you are getting the negative value, that is your -1. So that's why we are taking that if it is 1 and 0, right, target is equal to 1 or z is equal to 0, then we are getting that w old plus p, and if it is 0 and 1, then we are getting the w old minus p. And if both are the same, that is 1 and 1 or 0 and 0, then we get the w new equal to w old, right? There will be no change. So the whole algorithm, perceptron algorithm, says that these are the 3 rules which you have to take care of. Now I have given 1 or 2 examples, and next I will do the 3rd example also with the help of matrix. Till now I have given only this values and all these things. Now let us see with the help of matrix, and this algorithm we will do the MATLAB implementation also. Now just you can note down the problem, that is your P1 equal to, it is giving P1 equal to 1 and 2. This is your P1, 1 and 2, right? Should I write here? That is your P1 is equal to 1 and 2, and target equal to 1. P2 is equal to -1 and 2, target equal to 0. You have to calculate, so take your pen and paper, then you have to calculate with me. P3 is equal to 0 and 1, and T3 is equal to 0. So there are 3 targets and 3 inputs, right? Now 2 input and 1 output network without a bias, right? We have not given any bias this time. Without a bias we are giving, that means there will be 2 inputs and 1 output every time. The decision boundary must pass through origin, that I have shown, that if the point is like this, that means 1 and 2, that means target is equal to 1. For P2 target is equal to 0. For P3 target is equal to 0. As I have shown in yesterday class, that how to give the decision boundary, that also I have told you, right? So decision boundary should pass through the original or through the origin, right? Now let us start. Now P1 is equal to 1 and 2 and target is equal to 1. We are considering that W or the weight equal to 1 and -0.8. That we are taking consideration. Now how to calculate? Again we have to do the multiplication and the summation. Multiplication and summation when we will enter into the matrix form, because you will do in MATLAB. That's why I have given this problem, so that when you will enter into the MATLAB, we have to give the input as a matrix form, right? Now here we are giving that W and Xi. That means we have summation of Xi into Wi that we have given. So 1.0, or you can give Wi into Xi, anything you can write, minus 0.8 and 1 and 2. Now here you mind it that when we'll do the matrix multiplication, you have to take care that number of rows, number of columns should be, or the number of rows should be the number of columns of the second matrix, right? Here it is giving the number of columns, that is your, there are 2 columns, that is same as your the rows of the second matrix. If it is not, for example, you are taking W is equal to somewhere, it has been, you are entering like this. For example, you are entering like this in your command window of the MATLAB. Then you have to take that WT into P, otherwise it will not multiply, right? You understood my words? That means that when you are entering the value in the command window, that is your own wish that how you will enter the W values, right? We just give enter the value of the weight matrix. Now it is your own wish that you want to give in column format or you want to give in the row format. So if it is in the 2 rows, then it will be, you have to do the transpose, then you have to do the multiplication, otherwise the multiplication cannot happen. Now here we have given the column wise only and the column wise, and this is your row wise 1 and 2. So we have done the summation or the multiplication. What we will get? 1.0 into 1, right, minus 0.8 into 2. So you should also do yourself 1 minus 0.8 into 2 means 1.6, that means equal to minus 0.6. So we are getting minus 0.6, right? Now if it is less than 0, then it will be 0. If it is greater than 0, then it will be 1. The graph we have seen earlier in the yesterday class, that means it will be, sorry, it will be like this only. It should be through 0 only, and it should be the 1, right? Right? If it is less than 0, then it will be 0. If it is greater than 0, then it will be 1. So we should get like this. Now for this, the MATLAB says that, I have told in the yesterday class, MATLAB says that there is a command that is known as your hardlim, right? HARDLIM. So hardlim of minus 6, automatically it will give the 0 value, right? That means output is your A is equal to output. Output it is giving as 0. Now our output, what is the target? That is your 1. Now accordingly, what we should do? Z equal to 0 and T equal to 1. What we have got earlier? This is your equation, that if our target equal to 1 and Z is equal to 0, what you should do? That W new equal to W old plus P. P is your Xi, because we are taking that C equal to 1 and T minus 0. That means T minus Z, right? So T minus Z, what will be T minus Z? That will be 1 minus 0. That means what you are getting for your the new value. So we are getting the new value as 1 and minus 0.8. That was our W old, right? 1 and 0.8 plus P1. P1 is your X1, that is your 1 and 2. That means we are getting C into T minus Z into Xi. C equal to 1, target equal to 1, our output equal to 0. Our Xi is what? 1 and 2. That is in the matrix form. So basically you are getting the P equal to only 1.2 only. That's why we have taken directly as your P1, that is your 1 and 2. And when you will add, definitely you have to add in the column wise only, sorry, row wise you have to take. So W we have taken 1 and minus 0.8 in the row wise, and we have done the plus, and this is our new weights, that is your 2 and 1.2. Now this is our new weight. Now for the second purpose, that is your P2. Now we are calculating for the P2. As you have noted down, for the P2 we have the input as your minus 1 and 2. Now our new weight is your 2 and 1.2. So here we have written 2 and 1.2. Again we will find out the net. Now when you calculate the net, again you will get 2.0 into minus 1 plus 1.2 into 2. That is equal to minus 2 plus 2.4. That is equal to plus 0.4. Now if you take the plus 0.4, that is your, here it is your 0.4, and since it is the greater than 0, so hard limit of 0.4 will be, you will be getting 1, right? And what was our target? Target was, our target was equal to 0 in this case, but we are getting 1. We are getting here 1. Now what was the rule? Again we have said the rule. If T is equal to 0 and Z is equal to 1, then W new what it will be? W old minus P, right? That means W old was 2 and 1.2, 2.0 and 1.2 minus P. P means minus 1 and 2. Why it is minus P? Because T minus C is equal to 1 and T minus Z. T is equal to 0, Z equal to 1. 0 minus 1 equal to minus 1 only. So you will get the negative value. So minus P. P is your minus 1 and 2. That means finally we are getting 3 and minus 0.8. Right? For the next case, again we are getting the same case. We will be find out for the P3, and after P3 we are getting the weight equal to 3 and 0.2. In the similar process, we are getting here 1, and there also we must have the target equal to 0, that we have done the negative and all these things. After doing this, we are getting 3 and 0.2. This is our one epoch. Now after 3 and 2, again we have to see that whether we are getting the same value for P1, P2 or P3. Now P1 is your what was just only 1, I will check, that is 1 and 2, and target is equal to 1. So let me calculate. Now here in this case, the final weight equal to, we are getting 3 and 0.2. I suppose that this was only 3 and 0.2. And what is your P1? P1 is equal to 1 and 0.2? 1 and 2, sorry. So P1 is equal to is your 1 and 2. Now let us check, and target, they were giving that target equal to 1. Right? Now we have to check that with this weight, is it the same or not? We have to check for all the inputs, right? Now for one input, I will just check that again it will be multiply. So 3 and 0.2, this was our weight, and 1 and 2, this was my P1. Now let us do the multiplication and the summation. That was, sorry, 3 into 1 plus 0.2 into 2, that is your 3 plus 0.4. Right, that will be is equal to, sorry, 3 into 1 plus 2, right, 3.04. Now 3.04 is greater than equal to 0, what we have taken, and so the target will be equal to 1. That means first one is correct with this weight. That means we don't have to change the weight. Again we can change for the second one. You will see that you will get the target 0 only. For the third one, definitely you will get the 0. So that means we are converging to the actual value, right? So this is, I have told again, this was the rule. And what were the limitations? Now I suppose that I have considered the 3 problems. One is your very basic problem with the 0.4 and 0.3 with 1 points, right? After that we had done with the that 3 values, x1, x2, x3 with bias. And after that we had done that so that you will be able to do in MATLAB, so that how to give the input to the MATLAB. For that we have given to the in the matrix form without bias. That is your own wish, with bias or without bias. Now there are some limitations. Limitation says that linearly separable conditions. I have told in the yesterday class that what do you mean by linearly separable case. Now in the linearly separable conditions, this perceptron exists. But non-linearly separable conditions, perceptron will be extended to some network, right? Perceptron will not be able to converge the non-linearly separable problem. For this we have to do the extent of that is known as your Adaline network. That is known as your Adaline network. So this is a task. This is for you. I will discuss afterwards, that you will get some 10-15 minutes and you have to solve it. Now this is your, you can just note down, and I will ask the result that what is the final weight. I'll give 15 minutes to you, and after 15 minutes again I will just discuss. So this is your P1, just I am saying, I suppose that it is not visible maybe for the black. P1 equal to 1 and 1, P2 equal to 1 and 2, T1 and T2 equal to 0 and 0. That means for P1, T1 is 0, for P2, T2 is 0. For class 2, different class, P3, 2 and minus 1, P4, 2 and 0, T3 and T4 is equal to 0 and 1, P5, minus 1 and 2, P6, minus 2 and 1, and T5 and T6, that is your 1 and 0 in matrix form, right? For the class 4, P7, it is minus 1 and minus 1, P8 is minus 2 and minus 2, and T7 and T8 is equal to 1 and 1. This is equal to 1 and T8 is equal to 1, right? It may not be visible to you. T7 and T8, it is equal to 1 and 1, right? You can just note down that this is your task. You have to converge it with the help of the perceptron algorithm and you have to tell me that what is the final weight. I'll give you 15 minutes more after the class, right? Now, when we will do this perceptron learning algorithm, what are the parameters which can, help us to assess the algorithm, right? You can change anything in the perceptron algorithm, then what will be the objective parameter with which we can, check our algorithm, that whether it is right or whether it is better or whether it is best, right? Now, these are the various objective functions. First one is your classification accuracy, right? Classification accuracy. That means how much accurate it is for the classification. Classification means, I have told you, that is your 1 or 0, which class it is happening. I'll give you another example also for cost function, right? This is actually, formula is your that correct instances divided by the total instances. This is your classification accuracy. Now, what are the classification error? Error is misclassified instances divided by the total instances. That is 1 minus classification accuracy will be given by the classification error. Next is your pattern error. Now, what do you mean by the pattern error? Pattern error is given by only target minus output. That is only the pattern error. But there is some error we use here. One is your sum squared error. That is your SSE. SSE. One we use sum squared error. Another way is we use MSE, that is your mean squared error. Another we use, that is RMSE, that is your root mean squared error. These are the different errors value which we calculate and which we can see that how much reduction we have got in our algorithm, right? Now, squared error means Ti minus Zi whole square, right, for one neuron, right? If we get the sum squared error, that means it will be summation of, S means summation of Ti minus Zi square. That means total sum squared error will be summation of Ti minus Zi whole square, and I goes to 1 to your number of neurons n. Right? So this is your SSE and is your classification error and the classification accuracy. Next, I have told that is your MSE, right? MSE is equal to mean squared error, that is given by SSE divided by n. That is sum squared error, you have come to know, that is a summation of Ti minus Zi whole square for all the inputs or all the neurons, and that total divided by number of neurons give you the MSE, that is your mean squared error. Another one is your RMSE, that is your root mean squared error, that is your square root of the MSE will be given by the name has been given to root mean square error. So MSE is known as your average squared error per pattern, and the root mean squared error is the square root of the MSE. So root mean squared error is basically, what is the physical concept of root mean square error? It is the average distance or the error of targets from the outputs in the same scale as the features, right? This is given by the root mean squared error. Now, I have told you that if you want to do some, extension, then we go for the Adaline and the Madeline network, right? Adaline is your adaptive linear network. It is known as your adaptive linear network. And when we combine all the Adalines, that will be known as your Madeline network. XOR operations are done by the Madeline network. Adaline network is somewhat, it is similar to the perceptron algorithm, perceptron only. It has been developed by Widrow and Hoff in 1960. Widrow and Hoff in 1960. It uses the bipolar activation. You see, there we used to use the 1 and 0, but here we will use the bipolar terms, that is your -1 and 1. For input signals and the target values. Weight connections are adjustable with the delta rule only. And what do you say by the delta rule? Delta rule says that it is Wij into old value, target j minus out j into xi into a, right? A, that means delta rule. In Perceptron also we use the delta rule only. Delta is by name only, we can say that I have told you in the yesterday class also, t minus z, that is your delta value. That means that is the difference value. That's why we use that the delta rule. And when we will go for the back propagation, we will use the gradient rule. In Perceptron we use the delta rule. In back propagation we use the gradient rule, steepest descent gradient rule, right? That we will see. So in Adeline network also we are getting this type of equation. So Adeline training algorithm says there are some steps you can just see, that is same as your Perceptron. Initialize weights and bias, right? You can do at 0, 0, 0, 0. Bias you can take 1 or 0, whatever you want to take. Step 1, stopping condition. You have to give the stopping condition, whether you are giving the threshold or you are giving the error. For each training you do this step, that is your xi into si. This is your activation, that was your input, xi is equal to si. Next is your y input will be the b plus summation of, summation, s means summation of xi into wi. Then after that you have to update and the bias. If you take the bias, then you have to update the bias also. So bias new will be bias old plus a into t minus y in. Here you don't have to give xi. That will be the t minus y in only, right? A into t minus y in. Here we are giving that t minus y in is your the actual response, what you are getting. T is your target. So xi here we are inputting into xi, but in case of the bias new, when you are getting the updated bias, you don't have to input b old or something. So it is your a into t minus y in. So this way you have to calculate the w new and bias new. Again you have to calculate the new weight. So new weight will be w new will be the old and plus the delta, and similarly b new will be b old plus these changes in the bias, and again you have to go to the training procedure, and again you have to go to the stopping condition. So basically the neural network in every algorithm, the concept is same. You do the training again and again and again and again. Stopping condition is your own method. Either you can give your threshold or you can give the error, whatever you want to give. If your error you are giving the stopping condition, then each and every time you have to check the error, whether it is less than this, whether it is less than this. Up to that time only you have to give it. But Perceptron algorithm says that till you converge to the output or the target, you do the training procedure. So Perceptron basically is not meant for the complex algorithm. It is for the simple algorithm, because every time you will do the training, there is no error checking is there. You are coming to the only the targets. In back propagation, in considering the flaw of the Perceptron, in back propagation they have given that every time you can calculate that total target if you cannot get also, but somewhere you can keep the error percentage. That is, if you want that error percentage will be 10%, that it will be minimum, then you can get you can achieve your output. But in case of the Perceptron, it is not the case. You have to converge. Right, till you converge, you have to do the training and training and training. That means equal targets you have to get. So that is the difference between the Perceptron and the back propagation. But main procedure is this: you have to do the training, you have to do the validation, and finally you have to check that whether it is converging or not. Now this Adeline network, I'll just say that in Adeline, with the Adeline network, we have another network. I'll just insert one blank slide, then I will tell you that what is the Madeline network. What is Madeline network? Madeline network is basically what? combination of the Adaline network, that will be the Medallion network. For example, these are the Adaline network. What is inside is there, that is same. And here the inputs are coming, various inputs are coming to the Adaline network. Finally, the output of the each Adaline network, we do the AND operation, right? We do the AND operation and finally we get the output. So this is known as your Medallion network, M-A-D-A-L-I-N-E, linear. Right? So this is your multiple Adaline networks. This is known as your multiple Adaline network. That's why it is known as your Medallion. When you connect the multiple Adaline, these are all Adaline. So if these are 1, 2, and 3, then you can connect it with the AND operations, and finally you get the output of the Medallion networks. So this is the perceptron algorithm concept, that how we have come to know that who has developed it and what is the difference between the backpropagation and perceptron, because perceptron only converges into the target values, right? And you have to update the values. And what is the learning rule? Learning rule, it follows the delta rule, that is your C into T minus Z into Xi. If you are giving the bias, then bias also you can update. In the first program I have not used the bias. We have also updated the bias. You have you check it or not, that where we have given this bias problem, there also we have added this, modified this bias. In our case here, you can see that this was our bias, right? This was our bias. So we have taken that this one as a input, right? One input, and we have weighted. This is your bias, and corresponding weight corresponding to this, we have updated the weights also, right? So similarly, you can find out that bias also you have to update, and the inputs also you have to update, and finally you can get the updated weights, and you have to add to the old values, then you can finally find the new values of weight. Now let us take, let me complete this, and after this I'll give you just 15 minutes and you can just solve this problem. Mainly you can just solve one or two classes, because it will not be possible for the 4 classes again and again. Just you can check that P1 for the P1, P2, P3 and P4, what are the weights. Now I will ask to the each and every center, 1 or 2 faculty member can take a lead to tell me, and we will match it with the other participants of the other centers also. Now let us do it so that you can come to know that what is the basic algorithm, right? Let me close here and you do it, and after 10 minutes again I will come into the picture. Just one point, you have to consider the weights, right? Let us take the common weight, that is your W1 equal to 0.1 and 0.2. First of all, the weights you have to take, that is your 0.1, 0.2, right? With this we will do the calculation. Okay, the remote centers you must have done. So let me ask the remote centers again, that what is the output you have got after P4, P1, P2, P3 and P4. So what output you have given, you have got after P4. Now let me ask. So let me ask to Maharaja Surajmal.
After 4, it is 1.1 and 0.2.
0.2.
1.1 and 0.2.
Is it same for all the participants you have?
Yes, ma'am.
It should be 1.1 and minus 0.8. Anyway, let me check. Maybe the participants here, they must have done something wrong. So anyway, I'll just check it with the other centers also. Let me ask YMCA University.
x1 और x2 मैम टारगेट हमारा फर्स्ट केस में 0 0 है, तो वेट
हाँ
हमारे है 0.1 and 0.2
हाँ
and net 0.3 and output is 1 and 0 and dw1 dw2 is -1 and 0. मैडम पैटर्न जो बनवाया था आपने x1 x2 टारगेट वेट नेट आउटपुट dw1 and dw2.
हाँ
So what I have taken, I don't know what you exactly wanted. कि class 1 में हमने calculate किया. It is that I am getting the weight as 0.1 and 0.2, net is 0.3, and output is 1 and 0, and dw1 and dw2 is -1 and 0. And for the second case, I am just finding out my dw1 and dw2. I don't know.
Actually, what happened? Actually, basically, you have to take the first weight, 0.1 and 0.2, and you have to calculate up to P8 with
अच्छा.
all the weights, same weight, right?
Okay. So
Right?
up to 2 I have calculated. So ठीक है, fine.
So after P2, what you are getting the weights?
Weights I am getting as point it's 0.9, no, it's minus 0.9 and 0.2.
0.2
Minus 0.9 and
and 0.2.
yeah.
Maharaja Surajmal again, you have got after P2, you have got minus 0.9 and 0.2. Is it same? After P2?
After P2 same minus 0.9 minus 0.8.
Minus 0.9 and minus 0.8. Ma'am, that's why only I'm just telling YMCA, you can just take a calculation that check your calculation. After P2, it should be minus 0.9 and minus 0.8. But after P4, we are getting 1.1 and minus 0.8. But Maharaja Surajmal is saying that 1.1 and minus 0.2. There may be some calculation mistake. Say JSS Noida, have you done? JSS Noida? JSS Noida, have you done the calculation?
Yes, ma'am, we have done the calculation.
What values you are getting after P2?
Ma'am, after P2, there is a problem, like we are getting T equals to 0 and Z also 0. So do we have a new rule for that?
That means if the T is equal to 0 and the Z is equal to 0, that means there will be no weight updation. That means first of all, you must have updated the weight in the after P1. After P1, you must have updated, and that value must be minus 0.9 and minus 0.8.
Yes, ma'am, minus 0.9
Right?
and minus
So
0.8.
that means after P2, if there is no weight change, that means same weight will be there. That means W will be minus 0.9 and minus 0.8.
Yes, ma'am. That's the
Right?
answer. Yes, ma'am.
So that should be there. And after finally, yes. And finally, you have to do with this, we have to calculate the P3 also and P4 also. And P4
After P3, the weight will be same, minus
same.
0.9.
Yes, you are right. Yes.
And ma'am, after P4, the weight will be 1.1 and minus 1.8.
Minus, how it is minus?
And minus 1.8.
Why P4 is what? P4 is?
Oh yeah, for P4 it's 1.1 and minus 1.8.
It cannot be minus 1.8 because if your W is equal to minus 0.9 and minus 0.8, after that if you do the plus, P4 is your 2 and 0. So it will be 2 minus 0.9, that will be 1.1, and next one will be 0 minus 0.8, that means it will be minus 0.8.
Yes, ma'am. Minus, yes.
Right? It should be 1.1 and minus 0.8.
Yes, ma'am.
Am I right? So this should be your the value, and Maharaja Surajmal, again you just calculate, you should be 1.1 and minus 0.8, right? And DIT University Dehradun, DIT Dehradun, hello? You are not at all audible, and I am not seeing any participants in your center. Please put the camera on your facing the students, so that I can just get to know that how many students are there in your center. Professor Anuj Kumar Sharma, are you hearing me? So anyway, I'm definitely sure that you have come to know that how this perceptron algorithm goes on, and finally this way we have to do the weight calculation and weight updation, and after P8 the one training process will be completed, and after P8 again the updated weight we will calculate and all these things, till we get all the targets same as it is given, all the output same as given in the targets. Then only we will say that perceptron convergence we have achieved. So this is all about the perceptron. In the second half from 11:30 we will just start the back propagation algorithm.